Hey, this afternoon I just released homework assignment number 2. I released the document, but I forgot to include the link to the GitHub. If you go to my GitHub directory, GitHub/sfelixwu, and you can see that the first few repository, CPP01 was the focus that we have been talking about since the beginning. CPP02 is my break my hill. And now I have CPP03, which is a homework 2 reference implementation. You can actually see that. If you take a look at the file name, this file name sounds familiar to you. It should be familiar to you. Is based on CPP01, except it has a lot of stuff about JSON, JavaScript object notation. Let me see if I can see that. Nah, you didn't see that from the file name, but you will see that within the file. I mean, it has, for example, CPP. This one. At the end, you can see that we start to do this function, such as member function, such as dump to JSON, which I will explain to you why we start to introduce this concept called JavaScript object notation in the C++ programming. Okay, so that's announcement number 1. So I want to make sure you know that this Friday is going to be our first midterm. It's going to be 50 minutes. It's going to have 3 questions, and it's going to be closed book, closed internet. So obviously, I will give you the hard copy, and then whatever I'm going to asking is going to be until the Monday lecture. Okay, so you should review everything in the code, every lecture, and also the office hour, because office hour I gave important. Excuse me. If you look at my channel, my video has all the video. This is the first lecture. So now I have about 5 video included over there, which is actually pretty good. If do you know why I said it's pretty good? I look at how many views I'm getting. Lecture 1 has 88 views. And then when I talk about office hour for homework 1 is 194 view, which means almost everybody have viewed it. And then lecture 2 has 200 view, and we're trying to catching up this 2 number. I believe before Friday that this number will shoot up dramatically. Okay, all right. So so that's, if you haven't been accessed the resources, I basically just record everything, every activity from the lecture and office hour as well. Okay. Okay, I'm going to show you, continue what we did on Monday. Let me go back to, I'm actually in CPP01. This is exactly where I want to be. Let me make it bigger. So let's actually take a look at the test program. So we talk about a few things. One of the things we talk about is how to define a class, that we have been focusing on the single class called GPSDD. And then we talk about the difference between what is a class and what is an object. And then that's why when you declare an object, you just basically say what class it should be. And then you provide a variable name, which represent, that's the variable name is going to access to the object called GPS Home Woodland. And then when you create an object, that this object is based on the design which is laid out in the class. But this is a generic. And every single object is going to be different. It's just like every single GPS object is going to represent different location. Therefore, you need to have a way to initialize the value. Okay, so this line is class, object, and how to initialize the value of the object. Okay, so I actually give two different ways to do it. This is actually the old way, still valid today. When I first learned how to do C++ in 1987, I just yesterday after I said it, I said, wow, this was almost 40 years ago. And the thing is, this was the notation. I was creating object. But about maybe 15 years ago, they actually started to introduce this new construct called bracket initialization. They're semantically, syntactically, they're equivalent. Just programming language, they like to introduce a new way of doing the old thing. Okay, and they feel it is more readable that way. Okay, that's fine. I give it to that. Okay, so that's actually just one line. You basically know, okay, the most essential part about an object-oriented programming in C++. And then we actually talk about this distance function. If you remember that we actually talk about the distance, and this is the distance, by the way, is one of the 6 member functions. So over there, let's actually go back to the GPS.h. So this is the detail about the class. And it has a private. I hope now you know what's the difference between private and the public. And then you have what we call member attributes, such as latitude and longitude. And then we have a bunch of functions, which we call it member function. The member function, the first 2 is called constructor. So when I did the curly bracket, this kind of called bracket initialization, it's really calling the second constructor on the screen because it's actually match. This has 2 double, and then I declare a constructor with also 2 double, and therefore compiler know how to link this 2 pieces of information together, that you use bracket initialization to initialize an object, and then I found the right constructor to actually connect to that. Yes, please.
So the reason that you were able to input 2 values in the initialization was because you set the framework in that constructor. Right?
Exactly.
So if
Yes.
that wasn't there, would be there would still an error?
Right.
Okay.
Right. So if I actually do this, let me just, okay, by the way, I want to show this is the best way to verify what our understanding about programming language is. Just modify to see if it still works, right? We were guessing, okay, this is probably true. So I actually just add another one, UUBLE. I actually change this. And then I go to GPS.cpp. And then I change this to double XYZ. Okay, I just call it a new function. And now let's try to make it. Now you see that. See the error message I'm getting? It says no matching constructor for the bracket initialization. Okay, that's basically, thank you for the question. Is for us to verify that our understanding about the language and how compiler actually put these things together. Okay, good. So let me actually modify that back to GPS.cpp. So always watch for the message from the compiler, the error message. It really helps you not just understand what kind of mistake you had, but also really understand the language itself, okay? Let me just get rid of this. Okay, now I should be happy, get rid of this. Okay, then we talk about other member function, which is non-constructor. There are regular functions to do. By the way, there's another thing called destructor. So constructor is when you create an object, you call the constructor. But later we'll see example, which I have destructor, means that when you want to destroy this object, what kind of things you do in order to close down your object business nicely. But we'll give some example about how to do destructor. So we have a bunch of function. So I talk about latitude, longitude, and distance. This is what we talk about. Oh, by the way, there is another function called dump. But the difference I didn't show you last time is actually there was something new called operator overloading. You can see that what I did is operator minus, which that is the focus I want to talk about. So remember I told you we have a reference book. Just want to tell you where we are in the textbook. We kind of finished chapter 11. Chapter 11 is about class. So we're actually into chapter 12. If you want to actually get some extra reading, chapter 12 is about operator overloading. So I'm actually switched into chapter 12. And we actually talk about, let's actually just refresh our memory a little bit. We talk about this function distance. So let me take a look at the distance function. It's actually being implemented in GPS CPP distance. So the real distance implementation is very simple. Okay, it's basically it's a member function. Remember, member function always started with what's the class that this member belongs to. That's why it's GPSDD column. This GPSDD in the front represent that this is a member function of the class GPSDD. And sometimes the new C++ programmer or experienced C++ programmer, they actually forgot to say this. And when you forgot to say this, and usually the compiler will pick it up because you declare you have a function called GPSDD and you don't have it because you forgot to put the class label correctly. Then the compiler, when they link all the code together, they realize they missed one function. So I'm not too worried about you and I both make this kind of mistake. But when we look at error message generated by compiler, it should give us enough such that we know, oh, there's some place I must forgot to add this. Okay, so I think reading the compiler error message really help us a lot in developing software. Okay, so this is the GPS. The function name is distance, and this function essentially I said at the last part of the class is that if I have object, I only deal with some basic type, like a double or it's an integer or there's no argument. That's actually pretty straightforward. But when I want to deal with a computation that involves multiple objects, in this case, it's actually involved two objects of the same type. So let me actually refresh. What is distance? Distance basically say what is the distance in kilometer or miles between two sets of coordinate, two sets of longitude and latitude. And so the thing is that, well, conceptually it's not so hard, but from the programming perspective, how do I write a program when it's actually both correct and readable when it involves multiple objects? So this is the first way we do it. This is, by the way, the default way of C++ handle this interaction among multiple objects. Is that I have two objects, they're both GPSDD. So essentially, I decide one of the objects need to be the master, and the other object need to be the argument that actually go into this member function, and such that within the implementation of the master, you will actually do the computation because you need to gather both information together. So essentially, you will do this. That's why I have another, which is another object. And then the object, the master is this. So essentially, I call this function with this 4 coordinate, this latitude, this longitude, that's from the master. And then from the another, which is the object being shuffled in as the argument, is going to be using get latitude and get longitude, which is the standard way for you to access the information for any GPS DD object. So by doing this, I actually be able to calculate the distance between these two. So from the programming perspective, this is the code we're talking about. For example, if we say the GPS TLC UC Davis is this, and then we have, let me actually move this. Yeah, no, I want to keep it here. So the other one is GPS home woodland. Okay, so I have two objects. One is GPS home woodland, and the other one is GPS TLC. And then what I did is I actually create a variable, which is double called distance one. And distance one is essentially have the master. The master is GPS. So GPS home woodland is this, the code we just saw. So I'm actually calling the distance function associated with home woodland. So let the home woodland become the this I showed you earlier. And then you put GPS TLC UC Davis as the argument. Another. So this one is another, this one is this. Equivalently, because the distance is symmetric. So I can actually do this way as well. So I can put GPS TLC UC Davis as the master, and then put GPS home woodland as the what we call another. And the computational results should be identical. So in this program, if we run it, okay, you can see that the first two distance one, they're identical. Okay, so they're basically the same over here. Right, symmetric. Okay, now I'm going to tell you the third line, which is the third input. It's going to be another way to do the same thing, but I'm using a concept called operator overloading. So let me actually show you what it is. I'm not saying operator overloading is always appropriate, but it's an option for you to think about whether it's a good way to represent the concept you want to represent as a programming language. So look at this line, what I did here. This line. Okay, well, I give you a few seconds because sometimes you will feel this is a bit odd about why you write this piece of code. So can someone guess what I'm doing with this piece of code? GPS home woodland minus GPS TLC UC Davis. If I write the code looks like this, what do you think I'm doing? The programmer who wrote this code. Anyone? Yes, please. Okay. Okay, good. So it is an operator overloading because I already give the hint. So it's essentially, if you think about minus, if there was a two integer, you do a minus, or two floating point minus, the semantic is very clear, right? I mean, we just take that as a regular arithmetic operation. Right, subtraction. It's a subtraction. But the thing is that sometimes I want to write it in a way such that I actually give a different semantics to the same operator. In this case, it's minus. For example, I give you two person, and then one person minus the other person. What does that mean, right? I mean, depending on you're doing psychology study, you want to see what's their personality trait. They're actually different from each other, for example. And if this is biology, you do a minus, you might want to look for what's their age difference, or what's their height difference, or what's their some other kind of biological parameter that you would like to compare using that. So this is the general concept. So essentially, believe it or not, almost every single operator in C++, their semantic can be overwritten. So this is called operator overloading. It's an option to you but you don't have to use it, by the way, because sometimes it causes confusion unless it makes sense. I mean, for example, if I told you, if you believe me, this three line, okay, this three line number one, and this is line number two, and this is line number three. They're doing exactly the same thing. Let's do a vote. Which line do you think is the best way to represent what we want to represent as a programming language? If I give you three lines, line number one, line number two, line number three, they will be calculating the distance _1. It will be the same. The result, computational result, will be the same. But which way to represent it you think is the best? I mean, there is no definite answer. I'm not going to ask you this in the midterm. Don't worry about that. Oh yeah.
The first one and the second one, I think the third one is just a little bit confusing because when you're calling the distance function, it's like it gives you the shortest distance between these two places, right?
Right.
That makes sense to me. And if you're subtracting, the idea that you can subtract two values and have like multiple options is just very confusing.
Very confusing. Maybe I should use subtraction. I should use some other one, some other operator. Yeah, that's a good point. So operator overloading sometimes confusing, right? I mean, in this case, the first two maybe is like I have to decide who is a master, who is a slave, but at least it's clear, right? The function name is distance. Yeah. Right. Right. We try to provide exactly. We try to get rid of this who is the call, who is the object that's where the call based on. Yeah, please.
Maybe we need a neutral third party who is needed. There's like a static method in the GPS class that puts in two and then returns the distance.
We actually have that function. That's called friend function. We're going to talk about that later. But yeah, there is yet another which doesn't have a distance. It's just a regular function to include multiple of them. Yeah, that's a good point. Okay, good. Yes, please. You have a question? Okay, no problem. But anyway, this is the language. Operator overloading, unfortunately, is being used by many people, many programmers. So we have to understand, learn the basic mechanism. Yeah. Which line? Sorry, can you just speak a little bit louder? I cannot hear you. Okay, I will do that. That's what I'm going to do. Again, I'm going to explain. This is just telling you how to use it, but now we're going to see how the internal mechanism of this minus. That's your question, right? That's the subtraction. Okay, I'm going to teach you how to do a lot of things, but let's actually start with the minus. Let's go to GPS DD. First, look at the H. By the way, I just try to avoid writing a code. It looks like has a master, but internally it still have a master. So if you look at the way I do it is I actually I define a function called operator minus. So the keyword is that if you want to do operator overloading, you have to provide first the keyword operator and then put the keyword minus over there. And then you basically put in, still you can see the function prototype. It looks like this exactly. Okay, it still take the argument GPSDD as one argument, it still return the double. So essentially, let me actually go back to the code to tell you what is the syntactic interpretation about GPSDD, about operator overloading. So essentially, when I roll the code, looks like this. Distance is equal to this. So essentially what I'm doing is, this is the master. The left side of the operator is the master. And then the operator is actually going to be converted to be operator. So this line is actually equivalent to do this. Distance number one is equal to GPS home Woodland dot operator minus and GPS TLC UC Davis. Okay, this two line, they're actually represent the same line, but the second line just row won't compile. By the way, this is not an incorrect way to call operator overloading. You cannot just say object dot operator minus and then call that. The compiler, I believe, will fail if you try to do that. But essentially, that is the way you connect to the code. That's actually defined over here. When you define the code, you have to say operator minus, something like that. Okay. All right, so I'm going to comment this out. Now let's actually take a look at the GPS.cpp to look at its implementation. Look at what I did here. Okay, this is the original code that has the distance. You should be familiar with this now. But if you look at the operator overloading, what I did here, it's the same. It's the same. I just basically say operator overloading minus, and still another, and still calling exactly the same thing. So essentially, I'm just play some trick using a different way of representing the function using the mechanism called operator overloading, such that you might have a different style of reading in the code when you want to do that. Okay. So essentially, let me just tell you, you define an operator overloading, you use the keyword to say which operator you want to define, and then you use this way to define exactly the function itself. When you call it, then you just call it whatever operator you overload. There was a hand back. Yeah.
Both the word operator and word this, the keyword.
The operator is a keyword. This is a keyword as well. This is essentially a reference to yourself, to the object itself. Okay, so that's something which I should say this is that I could actually do this. I say this, I said double latitude is equal to 0.0. Assuming I add this line, the code here. First, do you think this piece of code syntactically is okay for me to do that? The first question. When I declare inside a member function, I said double latitude is equal to 0. Is this syntactically okay? It is. It should be okay. Let me compile. Every time I say it's okay, even though I know I have tried to compile it, but I always say, what happened if I didn't do that? What happened if this compiler change? Let's actually try to do that. Try to compile. It did. Okay, it can compile. Okay, so now the second question, wait a minute, it was GPS.dd, right? GPS.cpp. GPS.cpp. Okay, so if I declare this one, latitude, and it's okay by the compiler, that means I can give the same variable name to a local variable. By the way, this is called a local variable because this variable latitude is only available within the scope of this particular member function. So I can declare the same variable name to a local variable and to a member attribute, which is a latitude. If I can do that, then that's actually kind of dangerous. I don't know why the programming language actually allows this, by the way. Okay, I mean you're trying to confuse yourself, and therefore by doing this to this, I actually differentiate. By the way, I can actually do this. If I do this, if I do this, I don't use this. I actually use just longitude. Which longitude do you think this longitude referring to? It's going to refer to the attribute, right? Because you don't have it declared locally as a local variable. So there is a binding rule in any programming language is that the scoping that's actually closest to where I try to do the reference to that variable, that will be bound to that variable. So in this case, because I don't have a local variable, so this longitude is going to bind to upper level, which is in the class, which is the member attribute. But if I remove this, the second one, I'm going to be in trouble because this latitude is actually going to refer to this one instead of this. So that's why we always, let me try to see if this code can compile. I believe this can still compile. Yeah, it still compiles. And the thing is that, so that's why in C programming, whenever I access to an attribute, a member attribute, I always do this. Because regardless, you actually, somebody forgot and added a name looks like this, it won't affect the correctness because I always refer unambiguously to that. Okay, so just let you know that this is why this is kind of important for you to write the code. Okay. Okay, any other question? Okay, operator overloading. This is the simplest way for you to do that. Let me just try to run it and see how it works. Yeah, when I run it, you can see that the three lines, they're always the same. Okay, they're always the same. All right, so I'm actually going to give you a more general treatment for the operator overloading. Let me actually pull out my slide. Okay, so the other example, which is we try to compare, say, this is an object called box. So box has some kind of measurement. We would like to compare, for example, which box is actually bigger in terms of their volume. So therefore, just like what we did, is if you write a code like a box one dot compare volume box two, this we have to decide box one is the master. And we have to shuffle box two as another into this box. But instead, we can do operator overloading. Just say if box one is greater than box two. So I overload the greater than. Okay, so the code looks like this. Do I have that here somewhere? Yes. Okay, that's the code. You can see that inside the class box, I actually have a Boolean. So because I want to make sure that the greater than is a Boolean operation, so that's why I have a bool operator greater than, and then the other box to come in. Okay, that's a general. Okay, so I want to tell you that there is a lots of things that you can overload, except those operators you cannot overload. Okay, you cannot overload two columns because in C++, it has a unique semantic meaning. I cannot do that. I can do this. I can do this size off as well. Yeah, please. Which one? Why do I use a blue? Sorry, I cannot understand. You're talking about the color? Oh, Boolean, because operator, it depends on the operator itself, right? The Boolean is essentially, for example, this is called logical operator greater than. And that's why I actually decide greater than should return a Boolean. But it's totally the programmer's decision. I can actually write the operator greater than, and I can actually return the double, or return an object, return anything. So as long as the function signature match each other. So let me actually, that's actually a good point. Sometimes we actually underestimate the power of operator overloading. We thought the operator overloading has to semantically follow exactly what's the type, like a Boolean. So let me actually go back to this particular one. Let's take an example of person.cpp. So in person.h, you see I have an operator overloading, which is saying that whether the two person, they're the same to each other. So it returns a Boolean because equal is a logical operation that's actually compared to. So it's actually Boolean. But I can actually declare another one, which I say the operator equal is going to be, the difference is going to be integer. It's going to be integer. I declare this, the other one, and let's go Control X, Control 2, person.cpp. Let's first take a look at what is the original operator overloading. So the original operator overloading about equal in person is basically I just compare whether their social security number are the same with each other. So I basically return a Boolean expression and as connected to the function signature of Boolean version of operator equal. But I can remember I said it's an integer. I'm just using this as an example. Let me see. I just return this as an integer. If you have that, I just say return 1. Why don't I do this? It's easier. I don't want to write the rest of the code. Okay, I just basically, when you do operator overloading, I'm actually returning an integer 1 or integer 100, whatever the computation. So it's a different type, it's a different function. So let me first make sure it can compile, okay? Wait a minute, what happened? Yes. I actually differ only in their return type cannot be overloaded. Okay, I was wrong. That's sometimes I actually have some constraint about what kind of return type I can actually overload in certain operator. Okay, so I took it back. I have to figure out another way to do it. Okay, good. So sometimes you see that I thought it works this way, but then until I run the compiler, and the compiler will teach me that, hey, Felix, you're wrong about this one. Okay, thank you, compiler. All right, so now I want to actually go back to see I did actually change the type. Let me actually show you directly this example. I actually changed another one before the class and it works. You see that I actually change in the person, I do an operator minus a person object with a GPS object, and I overload it with a return a double, and it works. With a two different type of object, I can actually do the overloading. But apparently I cannot do this one. Well, I have to figure out how do I do that later. Okay. So any other question? Okay, good. So I want to actually show you the next one. So what I did is I said, okay, you can overload a lot of stuff, but I want to show you I have a particular way of overloading the let me actually do this for you. I missed. Okay, so that's good. So So which means that I have a bunch of operators such as operator equal. I can do this. But there are 6 operators, which we all call it, this is called the relational operator. This 6 operator, wow, this Zoom actually blocked the view. I want to move this down a little bit. And then I can use this one. Okay, now you guys can see. Oh, still on top of that. That's not good. Can you see it now? Okay, I want to use this one. So essentially there are 6 operator. Is equal, not equal, smaller than, greater than, smaller than, and equal, and greater than, and equal. Okay, there are 6. This is called relational operator. So when you actually declare operator overloading for this 6th one, in fact, you only need to declare 2 of them. Why is that? If I declare, say, let me actually show you an example. Do they have the example over here? Okay, fine. That's not good. I have, okay. So among the 6, you only need to define equal, and smaller than. You only need to define, because if you have this 2, then essentially you will be able to implement the rest of them. So that's the way to use operator overloading if they're actually, you want to deal with a relational operation, what we call REL OPS. The source code, I actually kind of listed a little bit over here. So let me actually show you the example. For example, if it's not equal, okay? Because I only define equal and smaller than. So how do I actually declare a operator equal, operator overloading that's actually not equal? So what I did is I actually call the operator overloading on equal, which is I already defined, and then just whatever result I have, just put a not in front of that. And similarly, if I want to return a greater than, because I already have a smaller than, so essentially I switch the parameter order between X and Y, then I can actually get greater than. So essentially I'm saying that the compiler really only needs us to declare a couple of this 6 operator. And then the rest, compiler will use this rule to implement the other 4. Okay, so that's why if you look at the people writing program on operator overloading related to relational operation, they only declare 2. And those 2 has to be equal, and the smaller than. With this 2, then the rest, it will be automatically generated for you. Okay, and using the standard template, that's actually on your computer. If you actually look for a pass looks like this, you will be able to see the code that's actually being used. Okay. All right, any question? Yes. Why is it ampersand after the class name? Okay, good question. So I haven't actually touched this topic. So anything with an M sign, you talk about M, right? M sign. Anything with an M sign is a reference. So historically, in C programming language, we actually only have 2 ways to access a variable or object. One is access by value. One is access by pointer. So essentially, what's the difference between access a value and the pointer is that when you actually call a function, if you call the value, so inside the function, if that variable got changed, the outside won't get changed. But if you actually access by pointer, then inside, if you change the variable, it will change that. So whenever, let me actually just go back to the code. see where I have that over here. Where did you see I did put the M sign? Which example? Right, over here, right? That's essentially this is the actually the systems code. So let me actually look for a code which I have that. Okay, for example, take a look at this. This code. I did the operator equal, and at the end I have an M sign. So what is the difference between putting the M sign and without the M sign? So the difference is that if I actually, without this M sign, when I actually want to execute the function, I'm copying the value of the object a person. So I essentially create a copy of the argument and then pass into my function. So within the function, when I'm actually doing any kind of computation, I'm actually compute the copy of the original object. But if I actually put an M sign, it's almost like a passing a reference. This is what we call object reference instead of a object copy. So essentially what we have is that this is the same object. The same object means that within that function, if I actually change the value of that object, then that change will be permanent, will be seen by outside of this function call. Does that answer your question about this is what we call the difference between call by reference versus call by value? Have you heard about this term called the difference between call by value versus call by reference? And then there was another term called call by name. But this is the last popular. The most important difference you should know is the difference between call by value and call by reference. Anybody heard about this term, call by reference, before? Okay, some of you. Okay, we'll review this concept when we talk about the pointer. Okay, this is essentially adding an ampersand. We're actually changing the call by adding and at the end of the class name. We actually change that to be a reference to an object. Okay. All right. I'm going to stop here, and I hope you understand what is operator overloading. I have one more example I didn't go through, which is this example, operator minus, and I hope you can actually go home to take a look at that. Okay. 1 second, let me actually pause the recording.